Okay, so three equations, three unknowns. I'm just going to do this one example because they're all the exact same problem. Once you can do one of these, you can do them all. The steps are the same for all of them. So your first step is to decide which variable you're going to eliminate. And so you mentioned in your post that you're trying to eliminate the y's, so I'll do it that way, just kind of show you where that would go. So what that means is I have to eliminate y from a pair of the equations. I'll go 1 and 3 first, and then I'll have to pick a different pair, so either 1 and 2 or 2 and 3. Pick a different pair and then eliminate the same variable. So let me show you that, and that's where we get that equation 4 and 5. So to eliminate that y using 1 and 2, I'm going to go equation 1, and then you had wrote in your post that you multiplied by 2, but it would need to be a negative 2 so that you get opposite signs here. So that might have been part of where your problem was. Okay, so equation 1 is 2x minus 2y plus 2z equals 1. And the second one, this would be negative 4x, and that makes that a plus 2y, which is what I needed, so they'll cancel. Negative 2 times 2 is negative 4z, and negative 4. And go ahead and do that, and this is going to be negative 2x, those cancel. Negative 2z equals negative 3. And so we're going to call this one equation 4. And now we have this equation that is in x's and z's. So if I can make another equation in x's and z's, then I can put those two together and solve them just like we did early in the assignment. So I'm going to go, which way do I want to go? It really doesn't matter. I'm going to go 2 times equation 1, I think. So let's go 2 times equation 1, and we'll add to that equation 3. So again, important, different equations, but I'm going to get rid of the same variable, the y. So here we're going to have 4x minus 4y plus 4z equals 2. And I'll copy down equation 4 here. X plus 4y plus 4z equals 7. So those will make a 5x, and we're going to call this one equation 5. The y's cancel. That's what I was trying to do, is get this come out negative 4, positive 4. That is 4 and 4 makes 8z equals 9. Okay, so with those two steps, I've eliminated y twice, and now I have two equations with two unknowns in x's and z's. And I think the z's are the easier one to eliminate, so now I'm going to put equations 4 and 5 together, and I'm going to multiply 4 by 4 to make this a negative 8z to cancel that 8z. So we'll go 4 times equation 4 will be negative 8x minus 8z equals negative 12. And I'll put equation 5 under there. That's a 9. So that's going to go negative 3x. Those cancel, and that's going to make negative 3. It looks like x will be 1. Okay, so once we have our first variable solved for, we can go back to either of our two equations, 4 or 5, and plug that in, and then use that to get our second variable. So I'll pick equation 5. It doesn't matter which one you pick. This one has less minus signs for me to get wrong, so I'm going to do that one. So 5 times 1 plus 8z equals 9. Yes, okay. Sorry, I had a second there. So that would be subtract the 5 on both sides. I'm like, is this a fraction? And I'm like, oh yeah, it was a fraction. That's right. Okay. So subtracting the 5 on both sides, so it's going to be 8z equals 4, and then divide that 8 over, and then we get z equals 1/2. So now I have 2 of my 3 variables, so I come back to my original equations, and it doesn't matter if I pick x, y, or z, they will all come out the same. I'm sorry, it doesn't matter if I pick 1, 2, or 3, they will all come out the same. So I'll arbitrarily pick equation 3, and let's see, x is 1 plus 4y plus 4 times 1/2 equals 7. So that's 1 plus 4y, that would be plus 2 equals 7. 4y plus 3, the 1 and the 2, is 7. Scoot that 3 over, 4y equals 4, and we get y equals 1. So our solution set is 1, 1, and then 1/2. So that is pretty much how all of these problems go. This one I had to do a bit of work every single step to get rid of it. Sometimes you get lucky. I think if you look back at problem 19 now, that one will look really easy. I think on your version it had a y and then a minus y and a minus y, and you can just add those together and they'll drop out, and then add them together again, the other two pair, and they'll drop out. You don't even have to multiply by anything, and you'll be right there at those equations. So that's kind of the basic what would happen. This particular one, I'm noticing as I'm doing it, if I had chosen to eliminate this x first, it does something kind of different. And I'm going to go ahead and show you that because you may run into this, and this really messes people up, and it's that it works too well. I won't solve it all the way, but I'll solve it to the point where you get stuck. Sorry, that takes a second there. Okay, hopefully you just made use of your fast forward button. Let's say I tried to put equations 1 and 2 together with the intent of eliminating those x's, which is actually when I looked at it, what I thought I would do. So let me go equation 1, and then I'll go -1 and 2. And it doesn't matter which one I put the negative on, it'll come out the same. Negative 2x, and then that would be plus 2y minus 2z equals -1. And then I'll copy down equation 2 here. 2x minus y plus 2z equals 2. So let's say I had made that my first step. Okay, these cancel. Cool, that's what I was trying to do. 2y minus y, that's y. But then here it's like, oops, the z's also canceled. Those are gone. Oh, y equals 1. Okay, that's what I got last time, but now what do I do with this? Because I don't have another equation. It didn't go quite the same way as the last one. So if you do this and two of the variables kind of accidentally drop out on you, what you need to do is eliminate x one more time. So let's say I do equation 1 and 3 together, and I'll do -2 times, that looks terrible, -2 times equation, oh sorry, no, my bad. I'm going to go equation 1 and then -2 times equation 3. So I'm going to eliminate these x's right here. So equation 1 is 2x minus 2y plus 2z equals 1. And multiply all this by -2. I could have also used equation 2 right here. It wouldn't have mattered. That's one of the things. There isn't any wrong step. You're just trying to meet the goal of eliminating an x or a z. The important thing is we're trying to keep y in there. So then we'll go 2 to this one, and that's going to be -2x, and then 2 times 4 would be a -8y, 2 times 4, -8z, and 2 times 7 would be -14. Okay, let's add those together. X's drop out, so now I have -10y minus 6z equals -13. That does not look reassuring, but hopefully this turns out well. Let's see, so we'll put the 1 in for the y, and that's why I wanted to make sure I still had a y in this equation, is because now what would have been kind of my equation 5, I can just plug that straight into. So -10 times 1 minus 6z equals -13. So that would be -10 minus 6z equals -13. Add the 10 over, -6z equals -3. And then there's that same z equals 1/2. And then I could plug y and z back into these and get x. So if you do happen to do one where the variable, two of the variables accidentally cancel in your first step, that's cool, you got your first answer. Just go back and do either eliminate, like in this case I knew y, so I would have needed to eliminate either x or z. I could have done, oh no, that would have eliminated there. So yeah. So there's no set way to do these, but again, your basic plan, put two of them together, eliminate a variable, put two different ones together, eliminate a variable, put those two equations together, and get your first answer. And that's it for these. And kind of once you can do them, it's really a matter of trying to not make sign errors. The math itself ends up pretty easy, but it's long and it's easy to make mistakes.